Most of your time in class today is going to be spent on just working through problems using Kirchoff's rules. They're pretty complicated and do require a fair bit of practice to get used to how to deal with them. So I'm going to work through a couple of examples with you, and then you'll be turned loose to work on some things. Yeah. So remember, we have the loop rule, which says that the voltage, the potential difference around a closed loop is always 0. We have the junction rule, which says the current entering a junction has to equal the current flowing out of a junction. So we can look at the circuit and we can start thinking about what's going on here. So what happens? Current comes out of the battery, passes through R1, splits down these two branches, then passes through R2, passes through R3, passes through R5, and then the current reunites, goes through R4, then passes through the battery, and continues on. So what do we see from this? Well, we can see that R2, R3, and R5 are all in series. So without even appealing to Kirchoff's rules, we can say that the current through resistor 2 is the same thing as the 1 through 3, and it's the same as 1 through 5. We can also see current passes through R4, then through the battery, then through R1. So we can also say that current 1 is equal to current 4. So we actually only have two unknowns in this case, and we can then figure out what they are. And since we only have two unknowns, we can actually write more equations than we have need of using Kirchoff's rules. So the first, I'll write a loop rule here. Write a loop rule going around this left loop. So we go through the battery. So that's 0 equals 4.5. We get a positive 4.5. Voltage drop through R1. Then a voltage increase passing through this other battery. Voltage drop across R4. And again, we can call that I1. Actually, I'll put in the numerical values of the resistances. And we can call this I1 because, as we established before, the current through resistor 1 is the same as the current through resistor 4. And so actually this is a pretty simple application of Kirchoff's rule. 4.5 plus 1.6 is 6.1. And then we move our currents to the other side, so they become positive. 20 plus 50 is 70. So we can solve for I1, which is the same as I4. Oops. And get that current is 0.087 amps. Whoops, I ran out of space on my paper. 0.087 amps. The A just barely fits on the page. All right. Now with the loop on the right, again, we go around. Starting here, we go backward through the battery. So 0 equals negative 1.6. And then we'll assume current's going this way. So then we have minus I2, R2, and R2 is 15. And I3 is going to be the same thing as I2. And R3 is 10. I2, R5, 25. So again, this is another fairly simple equation. We've got, well, we can see that the current is actually going to be going in the direction opposite of what I initially thought. What I initially assumed, because we've got a positive 1.6 equals a negative 15 plus 10 is 25 plus 25 is 50. So 1.6 over negative 50. So I2, which is the same as I3, which is the same as I5, is equal to negative 0.032 amps. So now we got our currents for that circuit. Now here's another circuit. It's kind of similar. but kind of not. And the difference we can see is that there's a resistor here and a battery over here, which is kind of the flip of what's going on up here. Those two spots are flipped. However, we can still write our various rules. So let's see what's happening. Current comes out of the battery, goes this way, splits down two junctions, and this junction passes through R5, then passes through R3, then passes through the battery, and then the current's reunited at this junction, passes through R4, passes through the battery, and then goes back to R1. So what do we see? Well, R5 and R3 are in series, so current 3 equals current 5. R4 and R1 are also in series, so current 1 equals current 4. Then we can write, at this junction, we can write a junction rule. We can say that I1 equals I2 plus I5. Current going in equals current coming out. And then, actually, I'll call this I3 instead of I. They're the same thing, but I'll call it I3 just because. And then we can write loop rules. The loop over here, you got 0 equals 15 volts minus I1 R1, which is 250 ohms. I've drawn the current as going downward. It may in fact go upward because this 25 volt battery, but we'll see. Minus I2 R2 is 100, and then minus I4, and I4 we know is equal to I1, so I'll put that in there. I1 times R4, which is 55 ohms. All right, so that's one of our loop rules, and then I'll write a loop rule over here. And actually, I'll start over here, just because I like going through the battery first. So we go through the battery, we get a 25 volt boost. We go backward through this resistor, so that's plus I2 times 100 minus I5, which is the same thing as I3, times that resistance minus I3 times R3, 320. So, I mean, technically we have 5 unknowns, but these two equivalencies reduce that to just 3 unknowns, I1, I2, I3, and then we have a matrix where we have 3 equations for each, and so we can solve for our 3 unknowns. Rearranging this one gives me 0 equals negative I1 plus I2 plus I3. Rearranging this one gives me 15 equals 250 I1. Oh, sorry, there's another I1, so 250 plus 55, which is 305 I1, and plus 100 I2, plus 0 I3. And then over here we have 25 equals 0 I1. We've got a negative 100 I2 plus 75 plus 320 is 395 I3. And just like I taught you the other day, we can write this as a matrix. Actually, for the matrix, you have to have your solution, your numerical answers over on the right side. So I'll do that with my equations, put the answers on the right side instead of the left side. And then we can put that into the matrix in our calculator. We can make a 3x4 matrix with the entries negative 1, 1, 1, and 0, 305, 100, 0, 15, and 0, negative 100, 395, 25, and then remember we do matrix math RREF, reduced row echelon form of the matrix, and we get the solutions for currents I1, is about 0.052 amps. I2 is about negative 0.0089 amps. So I2 is going upward as it turns out. I assumed it was going downward and got a negative. And I3 was about 0.061 amps. So we get our three answers. From there, I'm just going to have you practice working through applications of Kirchoff's rules, this assignment in the book, and then also I'm going to I'll have circuits set up in the classroom so that you can translate the physical circuit into a circuit diagram and then find the currents flowing through each resistor in those examples as well.